Okay, so this is the part related to the chapter which is we are going to study. Okay, these are already we have studied. Now today we are going to see that is nothing but the choice of specific loading. In that, first is nothing but the choice of specific magnetic loading, and second is nothing but the choice of specific electrical loading. Okay, now see, already I have told you, whenever we are going to study the choice of specific magnetic loading, that time we are going to concern on how much value of flux density we have to choose so that it cannot affect the different parameters. Okay, and next, as far as the specific electrical loading is concerned, we have to choose, or we have to select the ampere conductor in a such way that it does not affect the another parameters. Okay, so these are the two important points we need to consider whenever we are going to study the, what I can say, specific electrical and specific magnetic loading. Okay, now see, whenever we are going to concern the specific magnetic loading, the first factor on which the specific magnetic loading is depend, or the first factor which we are going to consider whenever we are going to choose the specific magnetic loading is nothing but the power factor. Okay, now see, by taking the reference of power factor, how much or how we are going to select the value of flux density, that we have to see here. Okay, now see what they have mentioned. If we select the higher value of the flux density, what they want to suggest is that if we select the higher value of the flux density, that time the value of flux through the air gap is increases. Okay, obviously you know that flux density, what will be the formula for flux density? Flux divided by area. If we choose high value of flux density, so that what it will happen? If we choose the high value of flux density, flux is going to be increased, because flux density formula is equal to flux divided by area, means it is directly proportional. So what will happen whenever we are going to choose the high value of flux density? So that what happen, flux through the air gap is increases. Now if flux is going to be increased, as you know that the current and flux are analogous phenomenon to the each other, so that what happen, if flux is going to be increased, it requires the large amount of the magnetizing current. Okay, due to the increase in the flux, and as this current is going to be increased, the what happens, which decides the value of power factor. So what happens, if it is going to be increased, then power factor will be obviously low. It's crystal clear rule that whenever we are going to use, or whenever what will it will happen, whenever we are going to select the high value of the, what I can say, flux density, that time what happen, the value of flux is going to be increased. And if the value of flux is going to be increased, so that what it will happen, it will increase the amount of magnetizing current, and the magnetizing current is responsible for, what I can say, for deciding the value of power factor. So if magnetizing current is going to increase, the power factor is obviously going to decrease. Okay, so that what it will happen, मग आपल्याला पॉवर फॅक्टर कमी झालेला चालणार आहे का? ओके, कुठलाही, you can consider what I can say, any electrical equipment. In that particular equipment, whatever the value of power factor, that should be nearly, what I can say, nearly equal to the 1. आपल्याला पॉवर फॅक्टर कमी झालेला, that is not, what I can say, acceptable for our system. So in order to, as per as the point of view of power factor, what we have to do, we have to choose the small value of the flux density. See here, last sentence is given, therefore from the point of view of power factor, a small value of a BAV is selected. BAV is nothing but the average flux density. Okay, very simple. See here, we have to choose the value of flux density. Okay, but by considering the power factor. Okay, by keeping the mode of the power factor. So how we are going to do it? First of all, what we have to do? First of all, if I will choose the high value of flux density, obviously what happen, the value of flux is going to be increased. And if flux is going to be increased, the value of magnetizing current is going to be also increased, which leads to the low value of the power factor. Okay, मग आता मला पॉवर फॅक्टर लो आहे, पण मला काय करायचंय, आय नीड टू इन्क्रीज दी पॉवर फॅक्टर. ओके, म्हणजे पॉवर फॅक्टर इन्क्रीज कधी होणार आहे, ज्यावेळेस माझा मॅग्नेटायझिंग करंट डिक्रीज होणार आहे. मॅग्नेटायझिंग करंट कधी डिक्रीज होणार आहे, माझी फ्लक्सची व्हॅल्यू डिक्रीज झाल्यावर. ओके, आणि माझी फ्लक्सची व्हॅल्यू कधी डिक्रीज होणार आहे, ज्यावेळेस मी फ्लक्स डेन्सिटीची व्हॅल्यू काय असेल माझी, कमी असेल. ओके, मीन्स आय हॅव गिवन यू दी एक्झाम्पल इन रिव्हर्स इंजिनिअरिंग पॉइंट ऑफ व्ह्यू. Okay, so means what we have to do whenever we are going to as far as the what I can say point of view of power factor, what we have to do, small value of the flux density that we have to select. Okay, high value of flux density select करायची नाही आपल्याला, काय करायचे, we have to select the small value of flux density in order to improve the power factor. Everybody got it? Now see, into the example or into the MCQ, what they will going to ask, if we have to increase the power factor, or if we have to what I can say as far as the point of view of power factor, dash dash value of BAV is selected. स्मॉल बिग त्याची काय तर रेटिंग देतील, व्हॉट एव्हर इट मे बी. किंवा ह्याच्यावर पण MCQ विचारतील, फ्लक्स डेन्सिटी इन्क्रीज झालं तर मॅग्नेटायझिंग करंट काय होणार आहे, मॅग्नेटायझिंग करंट इन्क्रीज झाला तर पॉवर फॅक्टर काय होणार आहे. They will ask the MCQ based on this point also. Okay, everybody got it? They will ask the MCQ based on this point also. So that what you need to keep in your mind, हे फक्त तुम्ही लक्षात ठेवताना कसं लक्षात ठेवायचंय, व्यवस्थित पॉइंट ऑफ व्ह्यू लक्षात ठेवा. सो दॅट व्हॉट इट विल हॅपन, इट विल नॉट मेक्स यू कन्फ्युजन. काय वाढल्यामुळे काय वाढते आणि काय कमी होते हे जर तुम्ही व्यवस्थितरित्या लक्षात ठेवलं, देन यू विल गेट दी क्लिअर आयडिया रिगार्डिंग दी चॉईस ऑफ दिस electric loading with specific magnetic loading with the help of what I can say power factor. Okay, so next point that we are going to consider, which is nothing but the core losses. Okay, now see, as you have studied in the what I can say second year electrical machine, as losses, core losses, hysteresis losses, CD current losses are depends upon most of the flux density. Okay, so what it will happen, whenever we are going to what happens, whenever the value of flux density is going to be increased, so that what it will happen, the losses is obviously going to be increased. And in any machine, if losses are increased, then that time what happen, the efficiency of that machine is going to be decreased. Okay, it will affect the efficiency of machine. Means your increased losses will always affect on the efficiency of machine. हे तर तुम्हाला you can study into the what I can say in the electrical machines, that if losses is going to be increased, your obviously efficiency is going to be decreased. Okay, so if I have to minimize the losses and I have to increase the efficiency, so that what I have to do, I'm not going to choose the high value of the flux density. I will show as less as value of the flux density. Everybody got it? Why? Because see here, as whatever the core losses are there, hysteresis and ED current losses are depends upon the value of the flux density. And if I will choose the high value of flux density, then what it will happen, the losses is going to be increased, which will affect the efficiency of particular machine. Particular machine in the sense, here we are studying the what I can say induction motor. Okay, so it will affect on the efficiency of induction motor. So how I can increase the efficiency? I can increase the efficiency by what I can say, by making the losses low. लॉसेस कमी करूनच मी काय करू शकतो, एफिशियन्सी काय वाढवू शकतो. ओके, सो इफ आय हॅव टू व्हॉट आय कॅन से, if I have to minimize the loss, then what I have to do, I have to choose the what I can say low value of flux density. Why? Because whatever the losses, hysteresis and eddy current losses, core losses, they are directly depends upon the value of the flux density. Everybody got it? So that's why we are going to choose what I can say, the low value of the flux density whenever we are going to design the whenever we are going to concern with the design of the induction motor. There is a reason behind this to choose the less value of the flux density. Okay, as far as the power factor is concerned, why we are going to choose the less value? Because if we choose the high value, then our power factor is going to be decreased. So if I have to increase the power factor, I have to choose as much as low value of the flux density. And second, as far as the core losses is concerned, the core losses, hysteresis and eddy current losses are directly depends upon the flux density. So if I will increase the value of flux density, what happen? The losses are going to be increased, which will affect the efficiency of that particular machine. And if efficiency is going to be decreased, then what I can say, we have to, if I have to increase the efficiency, so that I have to make the losses as low as possible. So how it is possible? It is possible by using the, what I can say, the low value of the flux density. How it is possible? By concerning the low value of the flux density. Everybody got it? This is our second point of consideration, that is nothing but the, what I can say, core losses. So by considering the reference of core losses, how to choose the value of the flux density. Okay, our next concern is nothing but the overload capacity. Now see, there is a one term comes here, that is nothing but the overload. Overload in the sense, as the name itself suggests, that if you are giving what I can say, extra load to that particular motor apart from its capacity. Okay, म्हणजे त्याच्या कॅपॅसिटी पेक्षा जर मी त्याला जास्त काम करायला लावलं तर ते इट विल बी कन्सिडर्ड ॲज दी ओव्हरलोड. ओके, आता जर सपोज take the simple example, if you are having the lectures of 4 hours, okay, and if what happened, due to the some reasons your lecture has been extended from 4 hours to the 7 hours, so what you can say, it is overload to the mean. Okay, means what happened, your capacity is of what, attending the 4 lecture, but due to some reasons what happens, you are going to attend the 7 lectures, means you are saying that I am gets the overloaded. Okay, the same thing is applicable to this induction motor, that is nothing but the overload capacity. ओके, म्हणजे त्याच्या व्हॉट एव्हर त्याच्या रेटिंग पेक्षा त्याला आपण खूप एक्स्ट्रा काम करायला सांगतोय. ओके, टू दॅट पर्टिक्युलर इंडक्शन मोटर, दॅट विल बी कन्सिडर्ड ॲज दी ओव्हरलोड capacity. Okay, now see, obviously a high value of BAV results in large value of the flux per pole. Okay, now see here, what happens if I will choose the high value of flux density? So what will be the formula for flux density? BAV is equal to phi divided by area, flux divided by area. Means what happen, whatever the flux density is there, that is directly proportional to the flux. Means what happen, if I will choose the high value of flux density, then the value of the flux per pole is going to be increased. Okay, so what happens, therefore it reduces the leakage reactance of the winding, and due to that what happen, overload capacity of the motor is going to be increased. When see, whenever you are studying, what I can say, whenever you have drawn the simple circle diagram into the second standard for the electrical machine, at that time you have seen the relationship between, what I can say, flux to the leakage reactance. Okay, so what it will happen, when the value of flux is going to be increased, so that what happen, whatever the leakage reactance of the windings of that particular machine is going to be reduced, so that what happen, your overload capacity of that particular motor is going to be increased. Okay, मग आता मला काय करायचंय, आता if suppose if I am the person, okay, I am continuously I am overloaded, if I have to reduce my overload, so what I have to do, म्हणजे मगाशी जसं मी एक्झाम्पल तुम्हाला दिलं, यू आर वर्किंग फॉर 4 hours, but due to the some reasons you are working for 7 hours now. So what I can say, यू आर ओव्हरलोडेड. मग ओव्हरलोड झालं तर मला आता ओव्हरलोड झालेलं मला चांगलं आहे का? इफ आय एम गेट ओव्हरलोडेड, सो व्हॉट हॅपन, it will obviously affect on my efficiency. Everybody got it? If I am get overloaded, or if any machine is get overloaded, so what happen, it obviously affect the efficiency. म्हणजे मला काय करायचंय, ओव्हरलोड कॅपॅसिटी ऑफ दॅट मशीन आय हॅव टू रेड्यूस. ओके, overload capacity of that machine I have to reduce. So what happen, how I am going to reduce the overload capacity? By selecting the small value of the flux density. Okay, overload capacity or overload for any machine is always affect on the efficiency of that machine. Why? Because जर सपोज त्या पर्टिक्युलर मशीनची एक काम करण्याची वॉट एव्हर दी कॅपॅसिटी इज देअर, every time it's going to be overloaded. So what it will happen, its efficiency is obviously going to decrease, and its efficiency is decreased, then it will what happen, what I can say, it will be not the good for that particular electrical system. So if I have to decrease the overload capacity, that time what I have to do, I have to choose the small value of the flux density. Okay, so as far as the overload capacity is, what happen, whenever I will choose the high value of overload capacity, or whenever I will choose the high value of flux density, sorry, that time what happen, the value of the flux per pole is going to be increased, which will result in the increase the leakage reactance, and due to that what happen, overload capacity of the induction motor is going to be increased. So if I have to decrease the overload capacity, what I have to do, I have to select the small value of the BAV, that is nothing but the flux density. Okay, now see, below that they have given which are the limits for the choosing the value of the flux density. These 3 points are very important as far as the MCQ is concerned. Okay, now see, whenever whenever we are considering any machine, general purpose machine, okay, general purpose machine, that time for that particular machine, the value of the flux density that we are going to choose is from 0.3 to 0.45 sorry 55 टेस्ला. म्हणजे एखादी जनरल पर्पज वापरातली कुठलीही मशीन आहे जी की आपण सिंपल फंक्शन साठी वापरतोय, त्याच्यासाठी व्हॅल्यू कशाची, फ्लक्स डेन्सिटी कुठून कुठपर्यंत असणार आहे, 0.3 टू 0.55 टेस्ला, ही त्यांची रेंज आहे. याच्यामधली तुम्ही कुठलीही व्हॅल्यू काय करू शकताय, सिलेक्ट करू शकताय. ओके, नाउ for a machine where large overload capacity is required. Okay, म्हणजे आता तुमच्याकडे एक मशीन आहे, you are having one machine with you, but due to the some reason that machine is continuously overloaded. So that time what will be the range for the flux density? The range for the flux density is from 0.6 to 65 Tesla. Okay, 0.6 to 65 Tesla. And if machine is very large capacity and that machine is high speed machine, then that time your value of the flux density is from 0.45 to 0.55 Tesla. Okay, everybody got it? What its value, 0.45 to 0.55 Tesla. Means these are the 3 points which are very important as far as the MCQ point of view is concerned. Our first point is nothing but the what, for the general purpose machine, its value is ranging from 0.3 to 0.55 Tesla. Okay, and for the machine which is continuously overloaded, so means at that time your value of overload capacity is continuously more, that time you are going to, or the range for the flux density is from 0.6 to 65 Tesla. And for the machine with having large capacity and when it is high speed rotating machine, that time you are going to choose the value of the what I can say flux density from 0.45 to 0.55 Tesla. Okay, म्हणजे आपण काल एक्झाम्पल पण सॉल्व केलं बघा. Yesterday we have solved the example. In that example, what value they have mentioned? 0.46 Weber per meter square. Okay, 0.46 Weber per meter square means what? We have to choose the value by considering the difference of this. Okay, So these are the 3 points that we need to consider whenever we are going to consider the specific magnetic loading. First point is nothing but the power factor. So if I have to increase the power factor, what I have to do, I have to choose the value of what I can say a flux density lower, not that much higher. Okay. Now as far as the what I can say second core losses is concerned, as losses hysteresis cd current losses, core losses are directly depends upon the flux density. If I will choose the high value of flux density, losses is going to be increased, which will leads to the efficiency of machine is going to be decreased. So if I have to increase the efficiency of machine, you have to what I can say choose the low value of the flux density. And as far as the overload capacity is concerned, whenever we are going to choose the high value of the flux density, that time what happen, your value of flux per pole is going to be increased, which will result in increase the leakage reactance. Okay, which will increase the or which will leads to increase the leakage reactance. And if leakage reactance is going to be increased, the overload capacity, what I can say, is going to be decrease. लिकेज रिएक्टन्स इनक्रीज झाला तर ओव्हरलोड कॅपॅसिटी काय होणार आहे, डिक्रीज होणार आहे. त्यामुळे आपल्याला काय करायचं आहे, वी हॅव टू चूज दी लो व्हॅल्यू ऑफ दी फ्लक्स डेन्सिटी. जर हाय व्हॅल्यू तुम्ही चूज केली तर काय होणार आहे, लिकेज रिएक्टन्स कमी होणार आहे, त्याच्यामुळे ओव्हरलोड कॅपॅसिटी वाढणार आहे. ओके, बट वी डोंट हॅव टू गो फॉर हाय व्हॅल्यू और कंटिन्युअसली ओव्हरलोडेड मशीन. आपल्याला कंटिन्युअस ओव्हरलोड मशीन नाही पाहिजे. So if I have to reduce the overload capacity of that machine, so what I have to do, I have to choose the small value of the flux density. Okay, and for general purpose machine, its value ranges from 0.3 to 0.55 tesla. For large, due to the some reason, if machine is continuously working with overload capacity, we have to choose its value 0.6 to 0.65 tesla. And if machine is with very high capacity and high speed rotating machine, its value we have to choose from 0.45 to 0.55 tesla. Okay, these 3 points are very important into the examination. If question will arises, write short note on the choice of specific electrical or choice of specific loading. That time you have to explain the choice of specific magnetic loading, and then you have to explain the choice of the specific electrical loading. So these are the 3 points which is related to the choice of specific magnetic loading. Which are the 3 points? Power factor, core losses, and overload capacity. Okay. 5 minutes are remaining. You can rejoin again.